Congratulations on completing the first few exercises and writing your first few programs. Thus far, we have just used Python as instead of a calculator, and this has hopefully not been too daunting. To go further, however, you will need to learn a little of the theory of computer programming. The videos that accompany this exercise will introduce everything that you need to know, however. This video in particular is going to teach you a little bit about variables. To be clear, the videos hopefully tell you everything you need to know to complete these exercises. Please don't spend hours Googling for programs that give the answers to these exercises. Doing so with Google is a recipe for producing code that you don't understand, which is not what we want. There is a place for Google searches in writing computer programs, but you need to understand the basics by doing these exercises before you start looking at other people's codes. With that in mind, if you don't understand, please ask your colleagues for help, or if they don't know, ask me for help. If you discuss the problem with someone else, it will help you to understand in a way that simply copying someone else's code will not. These warnings aside, let's consider what we have done in these first few exercises. In those exercises, you have written programs like this one here. When this calculation is run, the arithmetic operations in the expression are evaluated, just as if you had inserted this calculation into your calculator. And as a consequence, the answer, 30, is output. To me, even this is superior to using a calculator. What I like is that you can go back and look at the calculation that is being performed once it is run, and given your answer, which you cannot really do with a calculator. By being able to go back and check, you can thus see if you've made a mistake more easily. In addition, let's suppose that you want to take the answer that is output by this first sum and add 4 to the answer. Because we have done the calculation on a computer here, we can copy and paste the answer that we got into this new command and perform the calculation. Again, the operation of copying and pasting is less error prone than sticking the number that you just obtained from a calculation with a calculator into the next expression that you do with the calculator. Better still, however, you don't even need to copy and paste if you use variables. To understand what a variable is, consider what is shown on this slide. On the left of the screen, I have an empty box. On the right, I have the command set to 3. When I execute this command, a 3 is put inside the empty box, as shown here. In programming terms, this command changes the state of the box. Furthermore, if the command I give is now set to 5, I change the state of what is inside the box once more by replacing the 3 that is currently inside the box with a 5. Let's suppose now that instead of having one box, I have many boxes, and that instead of representing the state using a number, we represent the state using the box's colour. In the image shown below, all our boxes are thus in the blue state. Now let's suppose we want to change the second of the boxes shown here to the red state. Obviously, we cannot simply use the command set to red anymore, as there are 5 things we could change. The command set to red thus does not contain enough information to tell the computer what precisely you would like to do. On its own, this command could be instructing us to change the state of one of the boxes, all of the boxes, or the state of 2 of the boxes that have been changed in the movie shown here. What we thus need to introduce is a label for each of the various boxes that we have. For example, we can label the first box A, the second box B, and so on as shown here. We can then do what was shown in the movie by issuing the two commands set B to red and set D to red, as shown here. When these commands are issued, there is no longer any ambiguity. What we have introduced here is the notion of a variable. A variable in computer program is simply a labeled address that has a state that we can change using a set command like those shown here. The label of this address will not change in the course of our program, but the state of the variable, the particular value it takes, may change as the program executes. To make this idea more concrete, let's give some more examples of how we can use variables, but this time let's set the state of these variables to numbers, as this is more normal in the computer programs that we will run in this course. Here I have two example variables, B and D, and I have set the states of these variables to 2 and 5. What I've written here, however, is not valid Python. The Python versions of these two commands are shown here. As you can see, within Python, the equal sign is used to set the state of a variable. So the command b equals 2 tells the computer to set the state of the variable called b equal to 2, while the command d equals 5 tells the computer to set the state of the variable called d equal to 5. Notice here that the equals command does not mean the same thing as it means in mathematics. In mathematics, we use the equal sign to indicate that two quantities are always equal within our proof. Here, however, the equal sign is used to momentarily set the state of a variable to a particular value. The program shown here, in which b is set equal to 2 before being set equal to 5, is a perfectly valid Python script. As a mathematical proof, however, it is complete nonsense, as in a math proof, when we say b equals 5, we mean that when we say b equals 2, we mean that b is always equal to 2. We are now in a position to understand why programming languages and variables are so useful. They are useful because most of the useful programming languages allow us to write programs that are composed largely of arithmetic expressions that involve variables, like this one. In fact, one of the first real computer programming languages, Fortran, was named precisely because it transformed arithmetic formulas into machine code that the computer could understand. Fortran is short for formula translation. Why, though, is all this useful, you may ask? Your calculator can perform all the calculations that you require, and you don't need to learn anything about variables in order to exploit it. The answer to this question is that if you have a computer program, it can be used to repeat the same operation a large number of times. For example, suppose that you have a large numbers of values for angles, that all the values of these angles are in degrees, and that you are not a Babylonian but are instead a mathematician. A mathematician would always report angles in radians. We can write a short program to exploit the fact that 1 degree is equal to pi over 180 radians, as shown as follows. The program shown here does the following. It takes in the value of the angle in degrees from somewhere. It sets the state of a variable called pi equal to 3.141592653559. This is just the value of pi. It calculates the value of the angle in radians by using the formula that is in the definition above. It prints out the value of the angle in radians. Now, you could do all this with your calculator, but if you are converting 1,000 angles, entering the formula on the third line of this program into your calculator every time is going to be a pain. It is thus convenient to have this little program. Furthermore, I hope this simple example has convinced you that writing these programs is not actually that difficult. To summarize then, we have in this video introduced the notion of a variable. We have explained that a variable is an address in memory that has a label and a state. The state is simply the value the variable takes, and we can set the state of our variable using a command that involves an equal sign. Lastly, we have discussed how we can use variables in arithmetic expressions and can thus program a computer to calculate quantities for us. In the next exercises, you will use variables in expressions to consolidate these ideas. Good luck!